Okay, started the recording. Does anybody have any thoughts about the the chapter in general this time around? Okay, not hearing anything, so I will take that as a no. Yeah, okay. And I will try to monitor chat, but I might miss it, so let me know if um if I don't see your message. So to get started, I completely forgot about this tool, Aquascope, to look at um, the stack and the heap during runtime, and then as well the permissions that each piece of code has. Well, that each path has, better said. So we went through JavaScript for no reason, but we will see. Yeah, it looks like it's working. It's a little bit finicky, but to be fair, it does say it's a research tool under active development, and I am very grateful that it exists at all. So yeah, for example, here it shows us that at line 2 we have a stack, or we have the stack with the main frame, well, the frame for main, and then v is a pointer to the heap, which is this vector here. And then once we have n, that's a reference to the first element in that vector, and you can see it pointing to the first element. And then v.push pushes to that vector, and then n becomes invalidated because we're using it. I guess we can get into why later, but I think it makes sense to get into now. It makes sense for the example they leave on the website. Well, in this specific case, does anybody know why we can't do something like this? So why does Rust say no? And then why would this be bad if it were allowed to run? Why is that pointer invalidated? And feel free to type it in the chat. Okay. Well, in this specific case, the pointer to the first element is invalidated because a push, if we push to a vector, we don't know if it's at capacity or not. So if the vector's capacity is 3, then we need to reallocate memory. So deallocate this vector, and at that point afterwards, we need to allocate another vector that is larger. So this potentially, this reference could be a reference to deallocated memory. So if we do that, then we could have issues. Baguette. Okay, I see some new people in here. Did anybody else have any thoughts about the book in general? I just went over so far the um, there actually is a visualizer for the stack and the heap for Rust, and I just went through a JavaScript memory um, visualizer for probably no reason, but at least we know it exists now. Okay. Then let's get started in general. I know last time we went over, someone asked, or at least it was thought about, if Rust was the first time link or ownership was thought about. And the Rust book actually links to a study. And to be honest, I did not read it. I just want to mention that it's from 1998, so it is before Rust time. So it is not the first. And I will leave that in chat for anybody interested in reading it. It doesn't go into memory safety from what I've read. It just goes for it for if some objects in an object-oriented programming language understand, or if they're mutated without their knowledge, then that can cause issues. Like what we mentioned here. Okay. And then just as an overview for what we're going over this time around, we're just going to go over the ownership model, and we'll get a little bit into lifetimes as well since they're relevant here. And this will definitely not be the last time we talk about ownership because it's relevant everywhere. Like once we go over structs, you have to think about ownership there too. So we have to go over it many, many times. So let's get right into it. Oh yeah, I forgot I have to turn off the Rust server so no one can cheat. Okay, so if we have this function here where we have x and y, which are both numbers, and then we add them up here, and then print out the values of each one of them, does this compile? If it does compile, what does it print? If it doesn't compile, then why not? And what would happen potentially if it did run?
Compiles. Just prints out 5 plus 5 is 10. I don't see any issues with the assignments there.
Okay. Any other opinions? Everyone else agree? Sounds good. So running this, yep, it's perfectly fine. There's nothing wrong here. But what if we change those types instead? So if we run, oh no, I can't type. So if we change this x and this to y. So first of all, what types are x and y at this point? And what type is res?
X is a string, like capital S string type. And I don't know if Y is a separate like string literal type, or if it like converts it something else. But I think like string literal is like a separate thing. So I think it would give you an error.
And why would it give me an error?
I think it doesn't do a like an implicit conversion to like the capital S string type from a literal, but I might be wrong. I don't know.
So it would compile if I converted this one to a string.
Yeah, I think so. I don't know if the plus operator is like if that works in Rust, but if it does, then it would compile. That is.
Okay. Yeah, just to tell you, or like, yes, it does. You can concatenate a string with something else. I don't know, it's hard to say without giving it away. Okay, so for this specific case, this gives us a mismatch type. We expect a string slice, but we found a string. So
And is that for okay? So you can only add a string slice. You can't add two capital S strings together.
nope.
It could only be one. Like one has to be a slice. One side has to be a slice. One side has to be the type. Is there a way to refer to that besides just like spelling it out?
This is a string
Just slice
slice.
versus string. You
So
would just say slice versus
it's a
a regular string.
a reference to a string slice, but it's commonly just said string slice. And this is a string.
Okay.
Yeah. And there's some
And
good
then if it's a
differences
literal,
there.
you would say it's a literal, I guess.
I mean,
But
this
does
is
that
a literal in this case, yeah. So in this case, do you know? I guess we'll get into it. Let's finish this example, and then we'll get into like string versus string slices, because that's a good conversation to go down. Okay, so if I change this back, now these are the correct types. Changing this to the right type, does this compile? If so, what does it print? If not, why not? And why would it be bad if it did?
could just print 5 plus 5 is 55.
Okay. Any other opinions? I'll force y'all to write in the chat at the end at least. Can't just let Neon do all the work. Okay, well, the answer here is no, it doesn't compile.
Oh no.
But why is that?
So why? So like a string literal does convert to like a string by default if you just use a literal when you declare it. So you have to make it a slice.
These literals are slices.
Well, then why does it say it found a string type and it points at the Y in the error message?
Oh, because I didn't run this. I left it here
Oh, is that the
think
last
about
one? Oh.
to think about why it doesn't compile instead of just giving it away. Because now we know it doesn't compile, but why not? Like, these are the correct types now. This portion is fine. Like, adding this up is all fine, but all today, like right here, is the issue, print line. But why is that an issue?
Oh, hmm, what did somebody say in chat? Oh, I don't want to look at that yet. Is it res isn't moved?
Ooh, a move. Where would that be?
I mean X or Y, but I don't think that matters here.
Why not?
Oh, I guess they are strings now. So I guess you'd have to add them as slices so that you can still print them afterwards. Or something like that. Because you move them. No. Yeah, you move them when you add them and then create res, I think.
Yep.
The X and the Y.
In this case, we move these values. Like X is now pointing to deallocated memory.
Yeah.
But could we use Y? Like if I do this, does this work?
I think not. Unless it
Nope.
treats like it, I don't think literals are different. I think it creates a string. And so it'd do the same thing.
No, that's fine.
Weird.
So that's like a key difference of our. We have a string slice, but if we look at the type, I'll turn on the LSP real quick. So looking at the type, it's a reference to a string type. I know I said that, but it didn't show. Okay, here we go. So this is a reference to a string slice. So it's a reference. So we're not using up that value. You can't copy the string slice itself, but it's a pointer. So you're allowed to copy the pointer. So this 5 here is stored in read-only section of the program. So it's a reference to that section of the program. And then this X here instead is allocated on the heap and is mutable.
So I guess does it just hide the declaration away from you? Because I thought like string slices always had a reference to an actual string.
This is a reference. I mean, like it's not a string, a reference to like a specific string from the heap, but it is a string within the binary. Like it's stored within the program. This 5 is in there to be accessed.
Oh, okay.
So
So
yeah,
the references don't have to be heap allocated. It can be a reference to. Okay. Huh.
GC put something good in the chat though. Why does Rust allow a capital S string plus a string slice, but not a two capital S strings plus, or a capital S string plus capital S string? I wonder if it'll say, or if this will just be type error. Yeah, it's just a type error.
Hmm. Yeah, I don't know why. I mean, maybe it would be expensive because you'd have to reallocate a whole block for both of the strings, but I don't know how you'd avoid that even when just adding, like, lowercase str.
Well, if we this string, since it's immutable, it's valid for the lifetime of the program because it's just in the binary of the program. So once we have, at this point, 5 is valid for the entirety of the program. It's never going to go away. It's never going to change. It's just a section in memory that cannot be changed. So it's fine.
Wait, so does the lowercase str refer to string literals, like, as a type? I thought
str
that was something
is
else.
a string slice.
Right. So that wouldn't be like, it wouldn't necessarily be available for the lifetime of the program, only if it happened to be a literal. I'm talking about the
Oh, yeah.
question that GC posted.
This specific one is valid for the lifetime of the program because it's stored within
Yeah.
the binary. But if we had looked at a slice differently, like we said, this is, I guess this wouldn't be a slice. We have to do like, could we do that? Nah, because it's, yeah, at this point we have a slice. Wait, did it work with just 5? Yeah, okay, that's a slice either way. So at this point, this is specifically a reference to this x, and once this x is deallocated, this y is now invalid, and we can't use it anymore.
Mhm.
So yeah, that's true. That's a fair point. It's valid for as long as the data it's referencing lives. And I think I'm
Go
not
on.
exactly sure of the reason why you can't
Yes.
add a string plus a string, but you can add string and string slice. But there are ways to concatenate them both together. Like you could use the format macro to mix them together. So I don't exactly know the reason why, but I don't think it stops you because it's an expensive operation, at least, because you're allowed to do other expensive operations. It's not going to stop you. That's your choice to make.
Well, yeah, but they give you the option. Like, if you, like you said, you can still do it. You just have to do like a full format, like string, if you want to print it out, or you have to use another string method or something, concatenate them
Yeah, it looks
instead
like
of allowing you to do like the plus operator. There's probably some other reason.
we can push a char or push a string, or sorry, a string slice. Yeah. GC, do you know the reason why?
Tell us. We must know.
Spooky.
I'm gonna Google it.
So looking at the ad. Oh, fair enough. Yeah, that makes sense. Correct me if I am misinterpreting, but if we do string cap or string plus string instead of string plus string slice, then that API is you have to make 2 implementations. Whereas if we just did like this, we clone this x and y, and then do this here, we can reference this, and now it's implicitly coerced to a string slice, and this is fine. Well, this of course isn't fine, but line 5 is correct because we can add a string to a string slice.
Hmm.
Do you mean consumed as in it's unusable afterwards? Okay, that makes a lot of sense. I think you are right then, Neon. Just for anybody who's not able to read the chat watching the recording, Rust doesn't need to consume both strings, so it doesn't. So we only need a reference here, so we're only going to take a reference. So for example, another thing we could do is like if we had a get max function, it wouldn't really make sense to take ownership of that vector or mutate that vector because we don't need those permissions. It wouldn't really make sense to ask for the max of a vector and then you chose to do that by iterating by pushing or popping off everything in the vector, and then you're left with nothing at the end. Okay, that makes more sense.
Hmm.
And then also for anyone interested, here are the docs for the odd operator. Cool.
Yeah, so I'm reading through the string primitive docs. So yeah, when you declare literal, there's an implied static lifetime, and then every other time you take a string slice, it's going to refer to like the string that it has to be heap allocated, basically, if you haven't given it a static lifetime. Or I guess it could be on the stack, but it's basically just non-static lifetime, which is why that example you showed doing that.
And for anybody who isn't aware of a static lifetime, it just means it's available for the remainder of the program. And it is a reserved lifetime. Okay, going back to this original example, how could we fix this issue? And since we're talking about doing it idiomatically, what are some options and what do you think the most idiomatic way to fix this issue? What if we do want to know 5 plus 6 is 56?
You could take a slice when you, instead of using the plain x.
Take a slice of x instead of x?
I think so. Or I guess it's already a string slice, isn't it?
Is x a string slice?
Oh, not x. Y is, but yeah. You should be able to just take a slice of it.
Take a slice of X. That's what you're saying.
Yeah.
Okay.
Yeah.
So if I take
Oh,
a slice,
not add string slices.
so then we run into that issue again, the
Mhm.
difference between string slices and strings. So strings are mutable and growable, but a string slice is always the same. So for
What
example,
was the
this here is just in memory or in the program itself, in the binary. So it can't change, it's in read-only memory. And then this here doesn't change because it's just a view into the memory of X. And we now can't change it because we have a mutable or immutable reference.
I guess you could clone it. You hear me?
Yeah, clone it.
You could clone it.
Clone X. Yeah, I like that.
I mean, normally just not have the intermediate variable play. All you're gonna do is print it afterwards, but works if you need the variable later, I suppose.
So you're saying the other option would be to instead calculate in line what x.clone plus y is? Or just x plus y? Like here?
Well, I was thinking in the format, like if you did, oh, I guess you might still have to make a clone of it. I guess if you need both, if you need to print it out and keep the variable. Yeah, yeah, it's the same thing. I don't think you can do that in the format.
I don't think so either. Let's try it here. I guess you can't do that.
Yeah, you have to clone it. If you need it twice, you have to make a separate copy of it if you want. Yes, yeah, I don't see another way because you can't. I mean, you could just.
We do borrow x here.
Yeah, I mean, I guess once you make the res variable, you would just borrow res whenever you needed it. Use a slice instead. What?
I was just trying
All the
things.
parameters are evaluated before print is called.
Hmm. Oh yeah, this is not a lazy format. Fair.
Oh.
This will format this during runtime. Okay, so we can format it, but then if we do format, we are allocating a string.
Mm-hmm.
But there are crates like lazy format where we can avoid that. Oh, fair. Oh yeah, we are making a string anyway, so fair.
Yeah, the print line, like the format string, is basically just like an inline format call, right? I wonder what it.
Oh no, this is terrible. I'm doing that very wrong. I should have just done this goes after because we're formatting in a format. Okay. There we go. Finally. So this is, yeah, very interesting or very verbose. So I think out of the options we've talked about and that have worked, I think clone makes sense.
Yeah.
Yeah, and that's what GC is saying in chat as well. The dot clone makes it a whole lot easier, and then this way also is just a lot more work to get your print done. I wonder what is. It's just telling me that, but it's not going to fix it because that's fair. Oh, okay. Okay. So I have forgotten about Aquascope, but let's actually do that here and look at it and see why that may be. Unfortunately, it does not seem to work with string slices, but I'll do it just for what works. So, oh, maybe it'll work if I reference it. We'll see. Okay, let's see if this runs. And if it does, that will be pretty convenient. Yeah, perfect. Great. So just looking at the stack here, we can see we allocate a variable in the stack for 5, and then another one for the next 5. And then we have res, which is 10. And then once we do that, this is within a function call essentially. So it's not shown in this specific program. And this is all working perfectly fine. But this is a good chance to look at the syntax here. So with X, we have initialized this path here, and we're given read and ownership permissions. Same thing for Y, and then res, same thing here. And then once these all go out of scope, then we lose read and ownership permission of all of these, which is what you'd expect, right? Any questions about what any of that means?
This one just works because they're integers, right? So they copy.
Yeah, because they're copy. And we'll try it with to string. And see if it works. I think the permissions will work, but the actual stack frames may not, or the memory layout. Oh, it does. Perfect. I'm not seeing permissions, though. We will see if that loads. But while we're here, X is a string, so it's a pointer to the heap with this string 5. And then Y is the same. And then res, we clone this X and add a string slice to the end. So we have 5 and 5. Does that all make sense as well?
Yep.
For whatever reason, the permissions does not. Oh, there we go. Permissions finally worked. Okay. So here we have the same thing. But if we change this here, remove this clone, we'll see that issue. Yeah, perfect. Okay. So here, X is expecting ownership, which is fine. So it takes ownership here. And then it also has read rights, which it needs, and Y also needs read permissions. Maybe I should separate that out, but yeah. And then at this point, this is expecting to have read permissions, but it doesn't have read permissions. Because at this point, X is deallocated. So if we look here, yeah, we can see all this too. Great. We do everything else like normal. We make 2 strings. But then at this point, when we make res, it gets deallocated. We take the string that was an X, it moves over to res, and then we add a 5 to the end. So that doesn't work. And then at the end, we try to use X, but that's just pointing to empty memory. Does anyone remember what this kind of memory bug is called?
Use after free.
Yeah, exactly. Does that clear it up a bit more? Do you still have questions about it?
I'm good.
Okay. Okay, so for another example of that, let's see. We're going to make our own print function again, just like last time. So if we take this print function and let's just print X here. Does this compile? Or if not, or if it does compile, was it print? Otherwise, why not? And what kind of bug would it cause?
Pretty sure it doesn't compile. The X gets moved into the print function, and that would be basically the error message.
So what permissions does it lose at this point, and what permissions does it expect at this point? At line 8, what does it need that it doesn't have, and what does line 6 do?
Six, it's borrowed by the print function, and then it's deallocated once it goes out of scope because it was moved into the function.
Sounds like you're describing it moves ownership. It doesn't borrow it then, right?
Yeah, I guess so. Because the borrows are for like a slice. If you use the ampersand, it would be a borrow, which isn't being used there.
It doesn't
Like if you
necessarily have
change
to with the slice. But yeah,
the ampersand is like the borrow symbol, though, right?
yeah, it's a reference. Well, I
Reference,
don't know
yeah.
if it's a borrow symbol. I'll just say it is a reference.
But it doesn't it like a reference imply borrowing? I guess not.
The reference does borrow that value, yes. But I'm just not exactly sure of saying yes to that because I haven't thought about it. It could be true, could not be true. But yeah, okay. So you mentioned it doesn't compile because X is moved into the print function and then it's deallocated once it reaches the end of that scope. And
Yeah.
then because of that, what can't we do with X
You
and
can't
line 8?
use it. You can't use it after 6. After line 6 is executed because you're trying to pass in X. Oh, hold on. You sneaky. Is that print line? No, that's fine. It's still trying to use X. X, like the X in the brackets means it's still trying to use the variable.
Yeah, printline
I,
takes a reference to
I
it, but
thought.
it's fine. Like it doesn't, it's still moved into here either way.
Yeah.
So this
I
is a
thought it was a
bad
trick
print
question for a
API.
second.
It's not a trick question. I was going for, so X going into print means that it loses read permissions. This path does not have read permissions here.
Oh, that's what you were looking for. I didn't know. I didn't know what terms you were looking for the permissions.
And then what bad would happen, or what kind of bug is that? What would happen bad if Rust allowed this?
It's still like a use after free. Woof, woof, woof. You just got to bark along.
I'm not going to encourage this behavior. Okay, I'll just go for it and someone let me know if it's too annoying. But yeah, we want read permissions here. We don't need ownership at this point because print line takes a reference, but we cannot read this value at this point. So we needed ownership. That would also have been a different issue here, like if we tried to print again. But here we only need to be able to read that value. Yep, so if we switched back over to using our non-idiomatic Rust API, as we say, then this permission changes. It expected, oh, it just does not work. Oh, fair enough, because I'm passing the whole value. Yeah, there we go. So at this point, it needs both read and ownership permissions and has neither one. So this is a more unhelpful API. So does anyone have a suggestion how we would make this a more idiomatic API? Like, I personally would not expect a print function to take ownership of this value. What could we do instead?
Let it take a string slice.
So take a
Or
slice of,
what would you call it? Like it's like a ampersand str.
yeah, string
A
slice.
reference to a string slice, I guess.
Yeah. It's
Or a
just,
reference to a string. I guess that would work too.
yeah, which one do you think would be
Right.
better?
I think the reference to a string slice is more common since you can get a slice from any string easily anyway. But if you already have a string slice, you'd have to create a heap allocated capital S string if you wanted to use it.
Yeah, exactly. If we do it like this, then this would be perfectly fine. Because we're taking, well, actually, would this be perfectly fine? Ignoring this, does this work?
Only if you pass it a reference, or does it implicitly do that for you?
Things like printline are kind of weird in that sense, but every
Yeah.
function otherwise should. But yeah, good catch. It needs to take a reference. We have to give it a reference. So we will see. Or I can copy paste it and figure it out. Okay, it really does not like this. Okay, did I spell something wrong? Okay, yeah, I just spelled it wrong. That's what it's been doing this whole time. Oh well. I was ignoring that error message. But yeah, let's go over to VS Code real quick and see if that is the case. Yeah, okay. We have the macro. This is fine, but what if we do this? Yeah, exactly. You were right. So we need to pass it what it expects. And another reason why that's good, to make it even simpler, if we put these back, if I want to print something else, like I want to print hi here, like you mentioned, I have to convert to a string slice, so or convert to a string to get a reference to it. So to string and then reference here, which is pretty inconvenient if I want to print something, right? So if we switch this to a string slice, then this is perfectly fine. We can just print it.
Yippee.
Yeah, so it's implicitly coerced to a slice. So typically, if you're writing your functions and you have the option to pick between a reference to a string and a reference to a string slice, I'm not sure if there's any reason why you would need to do. Yeah, if you're just reading it at least, then this is a much better option because it makes your API much more flexible. But if you need some of the functionality of the string, then maybe you could do a string. Like if you're going to mutate an input string. It's a little bit different. Someone's asking if a reference to a string is the same as a reference to a string slice. And they are different. You can do some different things to the string slice. Like for example, we
Well,
have a string. Oh, sorry,
a
go ahead.
literal Sorry, I think isn't a literal just a reference to a string slice with a static lifetime?
Yes.
So like you could create a string from a function like that and it would behave the same as like a literal.
Like if I'm returning a string from here.
Yeah, if you had a function that was like make static string or something, and it would return a string slice with a static lifetime. I assume you can do that. I think it would behave the same way
As a string?
as a string literal or a literal. Yeah, it's a string literal
A
with it.
string literal would be that only way to get a string with a static lifetime, though,
No, you can
as far as I.
make a string. You can assign a. I mean, I'm gonna try this. Hold on.
I can
You,
show
you
you.
can
Okay, we
you
can.
can ignore me
Let's go through
and
it.
move on,
It's
but I want to
relevant.
see if it's possible.
It's relevant to the chapter. It's actually very relevant, so we should go over it. So you're saying, um, instead of this, we want to say, I'll call it like create string. And in this case, we are returning, I don't know, but we'll figure it out. So you're saying if we do something like this, it would be the same as saying, or like we take an input string and then return a slice of it. Is that what you're saying?
Yeah, but you would need to assign like a static lifetime to the passed in string. So I was thinking like you would pass in a string like at runtime, right? In your function, you can pass in like a string slice at runtime. Or it could be like a string, capital S, or a string slice, I guess. And then you should be able to create a string slice with a static lifetime and just return it
So you
from this
want
function, right?
to take a slice of whatever string you pass in and return it.
Yes, I think.
And that will work. Oh, you want me to give it a static lifetime too?
Yeah.
Okay.
Like,
Does anyone think it won't work or anyone think it will work?
I don't know what's gonna happen.
You're on the spot now. Yeah, let's use that function. So let.
To string.
Oh, you're typing it out already.
Yeah.
The answer is it doesn't work, but
No.
we'll get into why.
String. Just use a string. No.
So the reason why is we don't know if that lifetime is static because it's not static. Like we could assign it a static lifetime, but that doesn't mean it's true.
Okay.
So let's say, try that. Yeah, we're returning a value borrowed.
Ah, yeah. Okay.
So like, okay.
Yeah, it doesn't. It really doesn't like. Borrowed checker doesn't like you returning borrowed value.
So remember this, like we're doing hi is here. Like let's say string is equal to this, and then do that. So if we do this, string is owned here by string.
Yeah.
And then once we put it into slice, slice now owns string. We've moved ownership over to string. And then we're returning a reference to this value, which is then deallocated. Does that make sense?
Yeah. So would you be able to assign static to it before sending it to the function?
Would that help us?
I don't know.
Either way, okay, this is equivalent to saying like let s equals hi dot to string, something like this. Like this is owned by this function. So it's going to be
Yeah.
deallocated at the end of the function. So let's say we have this string, we deallocate it by at the end of this function, and now this is a reference to some deallocated memory. I wonder if Aquascope will let us see this. But yeah, giving it a static lifetime doesn't help us here because the truth is we are deallocating memory and then looking into that memory, which is definitely not going to go well for us. Well, maybe not definitely, but we get all that great undefined behavior. So we can see this. Yeah, so if you look at this, this program is fine to run. Like it's okay, it doesn't break anything. But if we use that reference afterwards, it won't be okay and will cause undefined behavior. So this one is fine. Like it doesn't hurt anything. But
But it doesn't
Rust doesn't
actually
allow us. Yeah, it doesn't make sense to do either, because if we look here, we're allocating a string. We're giving ownership of that string to S in create string, and then S is returning a string slice, and then that string is then deallocated because we hit the end of that function. So now the return of this function is just deallocated memory, and slice is deallocated memory. So this is a safe program because we're not using this value. But after this point, if we did something with it, like we try to print it, then we run into issues and we'll get that undefined behavior.
Kind
Yep.
of weird that it doesn't restrict the usage of the static lifetime.
Oh, it does. This is just Aquascope is a special version that doesn't require us to
Oh, it
pass
doesn't. It's not kicking you out at the compiler. Okay.
yeah, like if I do this at this point, if I start my server,
Yeah.
we will get all kinds of stuff here. Like we can't return a value referencing the
Yeah.
parameter. Which is just the whole issue here. And there's not really much we can do about that. It doesn't really make sense to do. And it will cause us issues.
I was just thinking the static like lifetime behaved more like a static keyword in other languages, but it doesn't because it's Rust and lifetimes are weird.
There's also a static keyword in Rust, but we're not talking about that this chapter.
Oh, god dang.
Okay, so how we would do this correctly is instead create this.
Well, you can't make a static lifetime string without just using a literal. Otherwise, it can't embed itself in the binary.
Yeah, it's not a part of the binary. You find out at runtime, and it isn't guaranteed to live for the remainder of the program. Like we just watched it be immediately invalidated, so we can't tell it it's static when it's not. So at this point, this is okay because we have a static lifetime, which means it's okay for the rest of the program. So now that we have hi in here, we can use it all we want. So this works, and we run it, and it's fine. It prints hi. But that other lifetime instead was not valid for the rest of the program. It was valid as long as string was valid. And string was immediately deallocated by virtue of this taking ownership.
String.leak. Is that like an actual method or something?
I'm sure it's a method.
String.leak.
Let's look at it. String.leak consumes the string and gives a mutable reference to the contents, which is the string slice. Oh, mutable string slices, that feels gross.
I can't find it in the docs.
Oh, well, I have the docs open right here on my screen.
Is this old version? It's weird. There.
Okay, well, take it with a grain of salt then. You can create something, a static lifetime from a string, but you can't just tell it it's a static lifetime. The actual lifetime is the same no matter what we do. But something else lifetime related that we won't really get into how to fix just yet, but we'll have two strings. And then instead here, we can do the longest function. And we're going to return a string slice and take in two string slices. I'm going to stop the server so we don't get any hints. These are horrible names. I apologize. So we could do something like this where we say if s is longer than t, we're going to return the longest. So we're going to return s. And then otherwise we're going to return t. And I will just say it here, this doesn't compile, but why would this one be an issue? Okay, I'm going to go a little bit faster since I've spent a lot of time on this one. So the answer here is longest returns one of these references. So it's only valid for as long as the reference lives. So string and string 2, once they go out of scope or get used up, then we can no longer do this. So if we use longest here, this one's fine because we know that string 1 and string 2 are fine. But if we do something different, like we get rid of string, we drop the value. I'm not sure exactly if it would work like that for a string. We'll see. But if I do this, I drop string at this point. This program would be memory safe because this is shorter. But if this one happened to be longer, then at this point we are reading memory, which has been deallocated. So we're getting all kind of lifetime stuff, but essentially it doesn't know which one of these strings we're returning, so it can't really be sure if this is okay to do. Because we could do something like this that removes that value.
Could you work through the lifetimes to make them both live as long as each other, basically? And then it would work?
Well, yeah, you have to do something where you're not getting rid of string at this point. So you can't change the lifetimes yourself by telling it what they are, but you can change them by saying, I'm guaranteeing that string and string 2
Well, can't
live.
you assign the lifetimes? Like when you do like a lifetime specifier, couldn't you like make them both have the same lifetime essentially? So if you dropped one, you drop the other. But if you still have one, you also still have the other. Is that how that works? Or
Yeah, it makes it the longest of the 2 lifetimes. And at this point,
right. Yeah.
since string is dropped and they have the same lifetime, then at this
It
point,
would drop the other one.
we can't use this.
But you'd have to do that manually, like manually assign lifetimes for all those.
Yeah, we'd have to do lifetime specifiers here. But we're
I
not
just
going
wanted
to
to
get
make sure
into
like
it
it
now.
was
Yeah.
possible. Yeah, we don't have to get all the way into lifetimes yet.
Yeah, it is possible, but it's tougher. So, like, if you ever run into a situation like that, you can always just clone the value. And most of the time, it's fine to do that anyway, unless you need like a super efficient program. Okay. We went all the way to the end of the the chapter probably without getting into most of the ownership stuff. So let's try speedrun. Okay. Let's delete all that. And here's another situation. So does this compile? If so, why? And otherwise, why not?
Going once, going twice. I think you get an error because I know you can only have one mutable reference to a value. I just don't know if doing like the y plus equals I would be considered a second mutable reference to it because you have the first one with the ampersand x, but then you're
Is that a
letting it
mutable
equal
reference?
y. So it's a mutable. Oh no, mutable reference is ampersand mute, but it's just a reference to a mutable variable. That's different.
Okay. So if we
It might be
change
fine
this,
then.
is this fine? So that was one of them, yeah. Well, I already said one of them. What's the other reason why this wouldn't compile? Or does it?
Oh, we've moved X. Oh,
Did we
wait,
move
can you
X?
even do that?
We have a
We
reference
use
to
the
X.
reference. Yeah. So first line, we create a mutable X. We have that points to, or it's not a pointer, but it's the string type. Then Y created with a mutable reference to X. And then we take Y, which is a mutable reference to X, and we modify it. I mean, it's just a reference. I don't know.
Uh, Hi. Uh,
Hey,
can you have more than one mutable reference to one value?
No,
no.
you cannot.
Yeah. Aren't we essentially doing that here, though?
No, we have one owned mutable path and then one mutable reference.
Oh, yes,
So
yes.
that specific piece. Yeah, I get that. That's a little confusing too.
Yeah, I see that.
Yeah, so here,
Focus.
let's find out. I wonder.
Do it.
So what is, but yeah, like what is Y at this point, first of all?
Well, it would just be high, right?
Yeah.
No, but like what is
Y
Y?
is, well, Y is a pointer to, it's a reference to X, right?
Yeah. And is the pointer mutable? Yeah, that's the thing here.
No, it's not.
The
I
pointer's immutable,
see.
and this
Tricky,
is,
tricky.
we could change what the pointer's pointing to, but yeah, here is our issue. We're not adding to high, we're adding to the pointer. So we can't
Oh,
use this value on a mutable string, but if we dereference, then this works.
Then you're getting back to basic original memory location. Interesting.
What if we do this?
So that's all that.
Yeah, you're getting to the
So,
original
but
memory location.
that ampersand, the mutable reference was necessary, right? So that you could
Yes,
actually
it's required. I'll go back to that, sorry. Like if it's an immutable reference, you cannot
you couldn't modify it at all.
modify that value.
Yeah.
So it cannot be borrowed as mutable.
Cool.
What about this? We have a value z. Is this allowed? Will this compile?
No,
Why not?
can't have two mutable references to the same variable.
yeah. More than once.
But at the same time,
They are at the same time.
that's true.
I mean, technically, like one is one line before it, like in the same scope. Yes.
Yeah, you were right here. I was just saying,
it's
like, you can have more than one, but it's one at a time. Like at this point with y, we're using y
Yes.
and z, and we're using this value. What if we do this?
Yes.
Is this okay?
And when you say at one time, it basically means like
For the lifetime of the reference. And reference slice times are a little bit different because
I was gonna say because it'd be in the scope, but it's kind of weird with reference.
Yeah, it's not in the scope anymore. Like once we stop using y, then y's lifetime is over. So if we look here,
Oh, yeah.
time to draw stuff. So yeah, if we look here, y's lifetime is here to here.
Fancy.
We stop using it then. And then z is another mutable reference in here. So we can't do that.
But you could, if you moved it after the reference to y, like all reference to y, you could declare a new mutable reference called z, a new mutable reference to x.
Yeah, we could do that. So now our lifetime is here to here, and we have another lifetime of just here. So this is okay. And then the same thing if we move it up. This is okay as well because these aren't conflicting at all. So another question. Is this okay? Does this compile?
Can you show us all the code? Yeah.
Yeah, sorry.
So wait, what'd you add? You added let z equals
This line here.
a reference to x.
Yeah.
Allowed. You're allowed to have one mutable reference, but I think you can have one mutable and one
Read only, yeah.
non-mutable reference.
Exactly. So this should work.
Interesting.
I think so.
Oh, someone's typing. We will see.
Uh-oh. She's gonna tell us what's what.
Yeah.
Oh, there.
The mutable refs are also exclusive refs.
That makes sense and is much easier to remember its usage.
Yeah, well, look at this. We have an immutable
mutable.
borrow. So like, why is that bad? Like, what bad would happen here if this was, we changed it? Why can't we do that? What's wrong with this? What would happen? That's a lot of questions, Ro. Sorry.
Oh, I guess Z is assuming that you have a non-mutable reference, but you could still modify it within the same scope using Y. You have that mutable reference. So you change the data
Yeah, exactly.
while Z was expecting it to be unchanged.
Yeah, beyond
Oh,
semantics too, we could possibly invalidate it, like that array example from before. So saying this array has gone not array, vector. Our vector has gone past its capacity, so now it's deallocated and a new vector is put in its place. So then in that case, unfortunately for Z, you're pointing to nothing. Or is that the case?
I mean, it could be.
I think this would be fine.
Because it's mutable, right? You could make it.
Yeah,
point
because
to
X
nothing like this.
is mutable, so it does expect to be mutated. But if we change this to immutable, then that would be where our problem arises, I believe. Okay, let's do a different example. Let's make this Y again. So what happens if we do that? Is that okay? If we dereference a reference variable.
It's not a reference, though. Oh, it is.
Oh, I apologize. I meant Y. Okay, sorry about that.
Oh, okay.
Thank you. Okay, if we dereference a reference variable, can we do that?
I think so.
Any other opinions?
Immutable borrow.
Nope.
Oh,
You're not allowed to do that.
move occurs.
So it doesn't
Ah,
say. Does it say? Oh, yeah. There we go. You can't
Please
move because
move.
it's behind a shared reference. So that's the rest reason why. But why would it be bad if we had two values owning one value? Or two bindings owning one value? What could go wrong there?
Oh, I guess you have. You don't have two pointers. Do you have two pointers to the same memory? No. I don't know.
What happens if these both go out of scope? Like what happens at the end of this function?
I mean, they'd be dropped.
Yeah. And does that cause any issues? If two bindings with the same value are both dropped?
Does it try to do a double? Would it do a double free?
Yeah, exactly. So in that case, we have a double free because now Z owns the value and X owns the value, and we can't have two owners. So the rest reason why is a value can't have two owners. But the programming reason why, I guess the
okay.
underlying reason is
So-
because double free.
It's like in C, if you had literally two pointers to the same thing, but in Rust, it's just implied at the end of the scope that it frees them.
Yeah,
And so it's not obvious, like just looking at it, because you don't have like the two calls to free, but it's implied because you have two references.
well, at this point, we wouldn't have two references. We'd have two owners of the same value.
Or
Like this
owners.
isn't a reference. If we had multiple references, that would be perfectly fine. Like we could do this. Like this is okay. We're allowed to have as many references as we want.
I was thinking of references in terms of like C pointers. But yeah, I see what you mean.
Oh, then yeah, fair. But the point there is when a value owning a heap allocated memory address or piece of memory goes out of scope, then its memory is deallocated. So yeah, it's because Rust works in that way that we need to do that. That makes sense?
Good guy Rust, saving our bacon.
Yeah, let's go.
Making double freeze.
Okay, yeah, let's get a little bit more into slices. So we already have a string here. Let's make it more fun and call it like Rust Book Club. So if we take a slice of both of these, so we can go 0 to 4. And at this point, this is not compiled. Oh, okay. The range cannot. Oh, okay, that's fair. I did a reference to an array with a range in it and not a slice. Okay.
Oh, okay.
So this is fine. And then let's say book club. So here we can omit this first part and then do 5 to skip the space to the end. and I didn't print it. So
What was the question?
oh, there was no question.
Oh,
I was just thinking about what to ask. I think it makes sense. Let's go over like.
I think
Oh, go ahead.
I don't think anything. You should keep
Huh?
nothing.
Okay.
I didn't have a question. I just need to stop talking.
Okay. Understandable. So yeah, so this is perfectly fine. And then one thing to keep in mind is if we, well, I'll go over it later. What if we do something else like we do clear? And then this takes a mutable reference to self, by the way. And it clears out this string. Does this compile?
I think it's fine since it's at the end of the scope, so you only have one mutable reference like at a time, right? Because everything else is dropped. There's no other references to book club or Rust variables.
Any other opinions?
I think it should run.
Yep, it works. And then just to make it more clear, since it's another good tangent, it's implicitly doing this and turning it into, well, I guess not. Implicitly takes a. That's interesting that that works without the mute there. Oh no, it doesn't. It doesn't. Okay, good. I'm glad. I was thinking, oh, that somehow worked, but it doesn't. It doesn't work because we didn't. X is immutable. But once we make it mutable, it is. And the reason why is because we implicitly borrow it as mutable. So that's what it means when it says can't be borrowed as mutable. It implicitly does this for you because it makes it a lot nicer to look at. So the dot operator is just syntactic sugar. So instead, we would have to do something like string clear. That might be the right syntax. Yeah, that is. You'd have to do it like this, and you would be forced to do the mutable reference yourself. So if I do that, it does not work. Does that make sense?
Why doesn't that last line work?
Oh, it currently does, but doing this does not work because this is
right, because
a
it
direct.
needs to be immutable.
Yeah, it needs to be mutable.
A direct what?
Oh, like we're calling it with the associated function instead of a method call. So if we do x.clear like this, it's implicitly borrowed as mutable. I forget to save all the time. Save, save. There we go. Okay, yeah.
So that's just Rust doing like its aggressive, like implying stuff for you.
Yeah, it's implicitly doing it. And then it also works the other way around. Like, for example, we could say let x equals 5 as an I32. Let's say -5. I guess it doesn't really matter. But we can do x.abs, and it works this way, as it should. We get a warning because we're using this variable. We're not using it. But this will work for any amount of references as well. So it also dereferences. So this is fine.
That's weird.
But if we did it the other way around, it would be a lot of dereferencing. I'm not going to guess how many that is or do it, but just know it's just some magic. And it is still... Oh, sorry, go ahead.
I was just gonna say, you're using Vim keybinds. You could copy and paste the ampersands and then do a replace.
Okay, fine, we'll do it.
But move on. Not important. No, I didn't mean it. You don't have to.
Whoa, I did it. Not doing it anyway. Okay, but yeah, that's a very good point. I go, like, don't think about it. But yeah, that works. But now that we know those rules, what if we do something like this? We print it afterwards. Like, what if we print Rust at this point? Is this okay? Does it work?
No,
Why not?
because Rust, which is used after the x.clear, is using a reference to x. And so basically the Rust variable hasn't been dropped yet. Point where you're calling the x.clear.
Okay.
And yeah, the reference is still required in X.
And what are the lifetimes of all these, just to get a better example?
Rust goes from its initialization down to the last line. Book club is from the initialization to the print line of book club, line 9.
Yeah.
And then X is the whole thing.
Yeah, exactly. Perfect. Well, X, since it is that value, since it's a string, it's dropped at the end of the function no matter what. But these, the references only live as long as they're used. Yeah. So you're right, but for the wrong reason, but you're very close. Yeah.
Oh, I see.
It's not dropped, but it doesn't conflict with anything, so it doesn't need to. But yeah, exactly. We mutably borrow. So like the issue here, what could go wrong here? This is a great example because it actually gets into why we don't want to mutate something whether there's an immutable reference. What could happen? What does debug Rust do that we don't like?
Use after free. Wait, no.
Yeah, I think you're right.
Is it? Yeah, because the x.clear basically frees x, or tries to. Right. I'm not sure. I don't understand exactly what the clear does. Like what it's supposed to be doing.
It mutates the variable itself. Okay, that is not the correct window. Okay, here we go. Perfect. Okay, yeah, here. We can see exactly what it's doing here. Let's find out. Well, actually, I think we need to do 0 to... Does it work? Oh, it's actually running. I have no clue. Oh, wait. No, it's gone now. Come back, please. So yeah, it tells us why we don't have write permission to this string. We cannot change it. Does this have like an error here? Can we not see it? Well, I found it doesn't work if we do this specifically. It honestly doesn't matter what this is, so I'm going to say 5 to 6. And then we can look at what it's doing.
Wait, why didn't the x.clear have write permission?
Because we have an immutable reference, which removes that permission.
Oh, Rust is okay.
Yeah, we're not allowed to. Maybe this will work, maybe it won't. I don't know if we'll be able to see it. Okay, I don't think we're going to be able to see it in memory, but we can at least see this. So yeah, we start out with write, read, and ownership permissions. Then we lose 2 of those permissions. We lose writability, and we also lose ownership. So we're not allowed to change ownership at this point. So like if we put it in a different variable that's going to consume this, we can't do that. So then this path here, Rust now has ownership, or the ability to change ownership at least. And then we can read this. And you can read star, but you can't do anything to it. And yeah, same thing here. And we're all fine. Well, yeah, we're fine here. And then once we stop using bookclip here, you cannot read, and it does not have own permissions either. And here we're allowed to read this value, but we're not allowed to write to it. Let me see if removing these print lines or something will let us actually see it. It is finicky sometimes. If not, let's try it with a vector. It should probably work with that. I don't know if clear is on a vector, but we can always change it. X of 0 is equal to 56. And let's see.
It has a clear, yeah.
It doesn't like it because there's a type error somewhere. Did I do something horribly wrong? Did I spell debug wrong or something? I don't know. It looks like this is fine. Just Aquascope doesn't like looking at it. But yeah, I guess we can't really look at it. But here's a similar thing. We're mutating within this value, within X.
Yeah.
So these guarantees aren't held. So like here we're changing what Rust actually is. And then we could also do the same thing and validate those pointers. I could have pushed to the vector, and then that would potentially make that, or like pop from the vector either. And now those values aren't there, or they've changed. I could shift, push, pop. You never know.
Never know X's next move.
Okay, I think we can do like one more thing and then call it a day because we are pretty deep into it now. But yeah, well, let's just go over some examples. So like, what do we think we should do? So like we have a function called max that takes in a vector. So we have a vector. I'm going to turn this off real quick. We have some vector, and let's say they're I32s. And then we want to return the max number, so another I32. So do you think it makes sense to pass in for either of these values to be t being any type, a reference to t, or a mutable reference to t? Do you think, what should it be? What would make sense to you?
You just mean as like the parameter?
I mean, both of these.
How we
Do you
should
think
define it?
both of these should be the actual value?
Oh, the
immutable
parameter and
reference,
the return?
or immutable? Yeah, both. Like, what should they be?
Okay.
What makes sense to you?
I mean, it depends on. Oh, we're just doing a max function.
Yeah, it's up to you. Like, this is a function that takes a vector and gives you the max value. What do you expect it to do? What permissions does it need?
It should just need read permissions, so you probably just give it a pointer or a reference the vector, and then you return the regular type in I32
Okay.
because you don't need to mutate the vector.
Anyone else have another opinion? Yep, I agree with that. I think that it makes a lot of sense. Like, we don't need ownership of the vector. It'd be really annoying if you had a max function that took ownership. We couldn't use it anymore. And then it also makes sense to not give it write permissions, because then at that point, if it mutates those values, like let's say you decided to find the max by popping each value and comparing them, that would just be very inconvenient. You either have an array with everything gone, or you have an array with, or sorry, these are vectors. I apologize. We have a vector that you can't use anymore, either way. So I think that makes sense. And another one. What if we have a sort function? We're going to sort. We're going to take in a vector. Should it be a reference, a mutable reference, the regular value, and then what should it return? What do you think?
You'd have to give the parameter a mutable reference so that you can modify. We don't have to. You could technically give a full copy of it, like just the regular vector, and you would operate on a copy of it. But I think it makes sense to give a mutable reference so that you can just modify it in place and then return the pointer to it probably, or maybe return like a status or the length of it or something. I don't know. Because you'd still have the oh no, you'd have to return the reference back out actually, because the value would have been moved, I think, into the function.
You give a mutable reference, does it move the value?
Oh no, yeah. Not if it's a mutable reference. If you do that, then it wouldn't be necessary to return a reference to it because you'd still have it from the callee location.
Anyone else have any other opinions? This one's a more debatable one. Yeah, I think I would agree with that. I would prefer a mutable reference to the vector and then either return nothing or a pointer to it. That's what I'm used to when I use a sort function. What about a different function? So let's say we have something that takes a hash set, or it takes a vec and then turns it into a hash set. So we have our vec, and then this can be whatever we want. And then we have a hash set of also whatever we want. Should it own these values? Should it be a reference, mutable reference?
Either way, you're gonna have to allocate for the hash set as a return. So you can probably just give it a reference to read the vector because you're gonna need to iterate over it. Get I guess the keys. It depends on what you mean by converting a vector into hash set. Because I would typically think you'd also want values for that. Um, Unless you mean you have like a vector of like tuples or something, and then you want to convert like the first item in the tuple, the key, and then the second item in the tuple to the value, which you could do. But it just sort of depends on what you have in that vector to start with,
Fair
how you
point.
do that conversion.
Do we want it to be, in this case, we want it a reference to the vector. We also have to pick for the type within the container. Do we want, which one do we want for all of them? So mutable vector, mutable inner value, mutable hash set, immutable hash set. What do you think? Lots of options.
I mean, I wouldn't say mutable hash set like for the return.
Do you think it should be a reference?
Well, no, the return type should just be a straight hash set. You have to allocate. Then you wouldn't want to return a reference. But for the vector, like for the input, I would say use a reference for the vector. And it wouldn't it depend on what's already in the vector, whether you need to reference by like the inner type?
Yeah.
Because what if you have a vector with just like tuples and it's literally like your key value is they're all integers and your other values are also just integers. You would just copy those anyway.
Okay,
There'd be
so
no
keep
point.
the type
But
of
if
the
one
inner
was
value
like
the same.
what?
Oh, so you're saying keep the inner value the same, so t should stay the same between both?
I'm not sure I understand how you're just defining a hash set here then. I wouldn't define them as the same inner type.
Oh, like this part here, like t. Like the type of their values.
Well, yeah, I don't know, because it depends, like, what data you have. Like, we just decide on, like, a set of data we have in the vector as input, and then we can figure out what we would define the hash set as. Because I
Let's say
probably
we have
would, right?
strings.
If it's just string, then I guess that works. But it doesn't problem is that doesn't define you still need to define a type for the values. Like, as a hash set, you have to define actually, this may not be true. I don't know. Is hash set a built-in or a standard library
Yeah, it's built in.
type?
It's a set.
So I don't know. I don't know what values are allowed as keys. Is the hash set typing here, assuming keys are all like strings or string slices, and then the type here is just for the values?
Let's just say you're allowed to do this. There's no issue with it.
Okay. Um. Yeah, I don't know whether you choose between string slices or full strings for that, to be honest.
Okay. Well, I think personally, we're making a hash set from the vec, or maybe like into vec would make you think differently. But I personally feel like this would take ownership of the vec and convert it into a hash set. Semantically, at least.
Well, okay. That
Like, that's
works, yeah.
a personal opinion there.
I would
Yeah.
probably call it like convert hash to vec or something then. I don't know. I don't know how you'd make that clear in the naming.
Yeah, it's just typical of Rust, I guess, to know, like,
Yeah.
if you have a map on an option, then that will take ownership of that option. But if you have a map on an iterator, it's fine. And you can reuse that value later. But yeah, I think that's a good place to end it off. I will leave you with an exercise for the reader. Okay, so to end it off, answer that question. What do you think makes the most sense to do this thing? And then try it out in your own code and see if it makes sense. Yeah. Okay. Any final questions before we go into feedback? And no worries if you just want to leave at this point because, yeah, it's been pretty long. Okay. Any feedback? Did you feel like it was too long? Probably yes. Was it at least a good make you feel like you understood better? Anything that could be better? Anything that wasn't great? Anything you'd like to see?
I like that. Thank you.
I also liked it. I feel like I really enjoyed the examples that we walked through with like the guided questioning. I always like those.
Like these examples or like all of them, including like
I mean,
just
pretty much.
throwing stuff in the middle and seeing if it works.
Yeah, I mean all of them, but in particular the ones surrounding what was it? Like borrowing with like the mutable references and like exploring the different scopes and like trying to work through problem and thinking about whether it's going to work before actually compiling it, like forcing yourself to actually like consider everything that you should be when you're writing it initially so that you don't have to like rely on the compiler to tell you what you did wrong. I think it helps me get a deeper understanding of all the like features and stuff that Rust has.
Yeah, it's kind of interesting to think about when you wouldn't think about things having ownership. Like maybe in JavaScript, you'd take values like a string from an array and just be fine with it. But maybe Rust is
Exactly.
not okay with it.
Yeah, I mean in JavaScript or Python, I'm just throwing around like everything's getting copied all the time. Like I never even think about it. But actually sitting down and actually thinking about it first before like trying to compile it is very enlightening.
Can I ask, when you say some answers are debatable, do they still have a right answer even if they're debatable?
I mean, that's debatable too. Like if you're saying maybe this one has a better answer than another, like there's more right answers and less right answers, but it's all depends on who's using your code and who's thinking about it. Like some people might take your max function and then they're like, okay, I want to take ownership of your value, clone it 30 times, and then return the value back to you. And most people would probably say that's a really weird max function, but it works. Or like the example with using a string slice versus a string as an input, it makes it a lot harder to use that API, in my opinion, but maybe someone really wants to do that. So that one's less, there's less evidence one way than another.
Awesome, thanks.
Yeah.
Yeah, those sort of questions like are pretty common across languages. Like there's like a rusty way of writing Rust code and like a Pythonic way of writing Python code and JavaScript and so on. It just sort of depends on what's more common in like the standard libraries and like what sub community you're in. Like people writing like React applications are going to write JavaScript differently than some other frameworks and so on.
Yeah. I'm sure someone watching the video who's more experienced with Rust will be like, hey, this is not the best way to do that. You should actually use this, this, and this. And yeah, so like everybody has different opinions. And we haven't even explored all the options. Spooky.
Oh yeah, more feedback. I like the aqua thing.
Yeah,
To,
definitely
like
recommend.
visualize the lifetimes. I'm gonna have to use that when I'm debugging.
Yeah, I think it'll be super helpful to like read the errors and figure out what exactly they all are. Because I brought up the concepts, but I kind of went pretty quickly through the error message themselves. Like can't move out a shared reference is the trying to dereference a reference. So if you memorize that one, then you'll know exactly what to do.
Yeah, I just love it being like visualized because you can get sort of lost in the sauce when your functions get more than a few lines. Trying to
Yeah.
figure out where stuff's moved and what you need to clone and reference, so on.
Oh yeah. And it really helped me for seeing the difference between like owned pointers and non-owning pointers, which I don't think I ever mentioned, but like the ampersand is a non-owning pointer because it doesn't take ownership. But if you have something like a string, then that is owned and it follows all of the typical ownership rules. And
What
move
do you mean when you have
semantics.
a string?
Yeah, like if I have pretend that's a string. So if I move this around and I say like let t equals s, then this value is moved into here and I can't use s anymore. But if I have a reference, then both of these are usable and they're both fine. So it's a non-owning pointer.
But I thought
Or
you said
this.
string acted like an owned pointer.
Yeah, exactly. So like if I say let t equals s here, then s is moved into t. We can't use s anymore. But
Okay, but it's still a pointer because it's like an object, I guess. So when
yeah,
you
it
use it, it
owns the
uses a
value
pointer.
inside.
Okay.
And yeah, those differences there, like t, its lifetime is the point it's created from the point it stops being used, but s will last till the end of its scope.
And that's true with like any object, right?
Any
Or
object?
is it? Well, like if you defined um like a hash set or whatever that has to be heap allocated, it
Yeah.
would do the same thing.
If that was a hash set, it would own s value, or if it's a hash map, s is going to own the hash map. It's an owned pointer.
Is okay, actually a question. Hash set, is that just a unique set of keys? Like it requires a unique set of keys versus a hash map, which could have duplicates or something? Like or is that just their version of a hash?
Hash map is key value pair, where you look up the values by the keys. A hash set is a hash map with the values with no value. So like it's a unit type, or in other languages it could be null. There's just a separate collection specifically for that, but it's essentially just a hash map.
I don't understand.
Ultimately, it
How
doesn't
does
matter what it was,
documentation?
just like we wanted to turn it from one value to another value.
Yeah, I think that's where I was confused because I was sort of assuming it was a hash map the whole time.
Well, hash map, yeah, I think it's fine either way. Like you could convert it into a hash map somehow. Yeah. Any more feedback before we end it off? Or I guess get into homework too. Okay. I'll cut it off there, but feel free to send it over or send me anything, any feedback in YouTube comments if you're from YouTube, or just in the thread in here. But yeah, homework is just next chapter once again. So we're going to get into structs. So, and then we'll go over ownership again, most likely, just because these own their values. But yeah, we can use some structured data after that point. Pretty fancy. Cool. I'm going to end it there then.